in programming, we normally start counting from 0 and not from 1. And for the while loop to run, we normally have what's called a counter. So this counter, what it's gonna do is that it will help the loop, the control to get something to work with. So for instance, we normally use this while keyword. Now I think you are while keyword, and this is a keyword, so you cannot use this particular keyword in any other thing because it's reserved to be used in Python. So while for example, counter is less than 5 or whatever it is, we want to do something. So we want to print counter. Okay, and then we want to, I hope my screen is visible enough. I'll make it a little bit bigger. And then print, and then what else we do here is that we increment the counter and then we get the output. So when we print this, so basically what this happened, we increment by 1. So basically what this happened, that's why we're getting that error. So we can just change this to count, and then, yeah, I still have it here, counter. So we have this output. We have this output here. We have this output here. So I'll explain again what's happening here. So what's happening here, we have these two numbers. So what is happening is that we have started counting from 0. We've started the looping from 0. So what is happening is we enter the loop, and then we start from a 0, and then we add 1 to 0. So when we add 1 to 0, we get 1. Then when we add 1 to 1, we get 2, and just like that. So you are seeing these are 1, 2, 3, 4, 5, 6. So you're seeing all these 6 numbers because when we add this to this, this to this, this to this. So this becomes the current count, and this becomes the current count. So in every current count, in every instance of the count, we add 1, and then we get the output. So even if we add this, so this will be inclusive, this will include 6. So now we have 6, because now we come out of the control. We come out of the control when a 6 is equal to 6, or the number that's less than 6. So 6 is equal to 6. It's either less than 6 or it's equal to 6. Okay, I hope that makes sense. And we did something here. We tried just to elaborate further on the while loops. We did this. So there was this prompt. So there was this, and then we had a prompt. So this prompt is just a variable. So I came up with something like this. Give me something, and I'll give it back to you. The program will spit back that thing to you. And I will give it back to you. Okay, so what is going to happen here? So, and then I used, and then I did another prompt. It's just concatenating, string concatenation, as we previously learned. So I'm just adding string to, I'm just adding, where is it? This enter, quit, and exit the program. So what essentially I'm doing in here, I'm just appending this to the other one. You see it in the exit. So I need a counter here, and the counter is just an empty message that I need. So in this is just an empty string that the loop will keep on populating this string, okay? And now we enter into the loops body. So this is the loops clause. So while message is not equal to the word quit, then we want to do something. We want to let's ask the user to give us the message. So we want as input because we don't need, it's not an integer. So this function normally just takes a string, and we have prompt. Okay, so and then we just print the message again. Okay, so I'll explain. Yeah, so what's happening here is that we are appending. Let me run it first. Let's run it first. Okay, so all right, I hope my screen is visible. Okay, so let me run the program. So when you run, it'll give me something. Give me something and I will give it back to you. So let's say hello there. The program should give us back what we've written. So it gives us back hello there, as you can see there. And we enter into what's called an infinite loop. So it keeps on asking, give me something. If I say hi, the program will keep on giving me that. But if I enter quit, then we quit, you see, and exit the program. No, while message. So we are supposed to, if we enter quit, we should exit the program. Yeah, we've exited the program. And you can see it's given us quit here, and it's exited the program. Exit. Yeah, let me do it again. So I'll run it. And if I enter quit, we exit the program. And you can see here, it's exited the program. But if I enter something else, then it keeps asking me, keeps giving me back that. So we are still in like an infinite loop, okay? So whatever I give it will give me back, but if I enter quit, then it quits, okay? Yeah, so that's one thing that we tackled yesterday. And we also, we played, let me see. We did this as well. We were trying to loop, we had names, several names, and a list that contains names. So we can say dear, yeah, George, whatever it is, George, Manu, yeah, we can do anything. And so what we want to do here, we want just to keep on repeating this name. So what did I do here? So I did this. I used two loops for name in names. And essentially what I want to do here, I just want to iterate through the names. Iterating just means I want to loop over. I want to loop through the names. Like, okay, not this time. I'm not looping. Yeah, I'm looping through the names, and then I want to print them. So for name in names, count is equal to 0. I hope I can remember. Yeah, for name in name, count is equal to 0. And then, what did I do? Am I forgetting? Print count is equal to 0. And then, oh, am I forgetting what I did? For name in name, count is equal to 0. So while for name in names, did I use a while loop or what? Catherine, can you remember? Let me just check. Let me check very quickly. Oh, yeah, I have it here. Okay, I've seen what I did. So for name and count and welcome. So for name, we initialize a variable. I think we initialize first. Yeah. Okay. So the first thing that we did here, we initialize the counter, and this counter can be any variable is equal to 0. And then for name in names, so that means for every name in this list. So while count is less than 5, for instance, let's print the name, and we come up with something like this. Oh, we've entered an infinite loop. Yeah, this is very dangerous for us. So I've killed that kernel. So we've entered an infinite loop because I did not increment counter. So this is what normally happens. You have to increment it by 1 so that it keeps on. So that what we call, like we can just say a target. Yeah, I'm doing very fast because I don't want to eat into Bobby's class. So you can see dear, but yeah, so it prints for us dear, but it's not printing for us all the names. Why? Let's put the count inside the loop. And see if this will change. So this prints everything for us. Yeah, the way we want. And so this is okay. So we can even put this one here just to make it, give it some sort of readability. So because of this one now, if I put this divider here, I'll have some divider. You can see here, it's divided for us. And now it's horizontally placed. Okay. Yeah, this is just to, when we start dealing with a lot of data, you will learn this. So you can see this prints repeats for us dear 3 times, as long as this condition is still there. So while loop, how it happens is as long as this condition is in place, then the body of the loop will continue to run. Okay. So as long as this loop is in place, the body of the loop will continue to run. And that means as long as the count is not more than 10, it's under 10, so the loop will run. So when it gets closer to 5, or when it's equal to, or when it's 5, then the loop stops. And we stop there. All right, so we did that also. We also did, let me check. This is another, we didn't do this, but I wanted us to. So I want to initialize, I want to add certain sums of number. I want to initialize, this is the variable. The numbers are 10. So these numbers, I want to add these 10 numbers, okay? And I want to initialize sum, another variable called sum, which I'll initialize it to, I think 0. And I'll initialize another variable. This is the counter now to 1. Let me initialize this to 1, okay? And now what I will do here, let me see. Let me use the while loop. So while a sum is less than num, as long as sum is less than num, then what do I want to do? I want to add 1 I to 1. Yeah, I want to add that one there. And I want also to use the counter. So I want to add 1 to the counter. Okay. I hope you're seeing what I'm doing. So I want to add 1 to the counter. And then I want to print sum. So let me check if we got it correctly. There's something that while sum is less than num, just a minute. Let me check if I've left something from how I did it. I did it in a couple of ways. So, okay. I've seen how I did it. While I is less than, yeah, okay, all right. It's while I is less than, okay, because I is the counter. So, sorry for that. So while I is less than the number, because this is the number, as long as this one is less than 10, so the loop, the while loop, the body of the while loop will, this code inside the body of the while loop will continue to run. And what we are doing, we are incrementing 1 to some to this, and then we are incrementing the counter as well. And then we can say that you can just do it sum. This is the sum of like this is the sum. And of course, you know, I like this a lot. This is the sum. And so this will give us a nicely formatted string as an output. This is the sum. So what if I print it out of the while loop? I don't need all, and let me print it out of the while loop and see what's going to happen. So it's 45. I'm not quite sure if that's correct because I got 55 previously. This is the sum. So I did it in different ways, and I'll explain how I've done it in another way. Also, this is the sum. So let's believe it's that that when we add those numbers, we get that. We can check in theory. I don't want that. So what basically, there's a shorter way of doing this, but we are just playing around with these loops so that you get the hang of it. Okay. So another way of doing this, I can wrap everything in a function. I tend to like this, but I can wrap everything in a function. So sum total, let's call it sum total. So sum total, and then I'll pass, I need something to pass here. So let me call whatever I'll pass here to be nums. And then I'll initialize a counter, which I'll initialize to 0. And then I'll use for num in nums, or numbers for that matter, which is an iterable. So that could be a dictionary, a list, or a tuple. For num in numbers, so I want to do something. I want to add those numbers. So total, I'm just adding total. This is just the short of, we can even write it this way: total plus num. Okay, total plus num. And what I'll just do, I'll just return. We haven't done functions, but don't worry. I'll just return. I'm using the return keyword. Then I'll just return total. Okay, and that is it. So what essentially I'm going to do here, I've defined a function called sum total, and that does, this is just because I want to use that particular name because of what the function is doing. The number is, this is an argument that I need to add to a function, and this is just an initializing variable. So we know we can have a place where we can start from. So if I run this, I'll explain further. If I run this, it will not work. Why? Because I need to define the function. I need to call the function. So this is how we call a function, with the name of the function. And I need now to pass an iterable here. So this iterable, for now, let's create a list called numbers. And this list, let's add them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, so now I have something that I can work on. So when I'm calling this function, then I need to pass in that argument that I've used before. And we are not getting what I want. Let me check sum total. There's some total. Why it's not? It can't be 1, of course. It's not worked the way we want it. Total for num in numbers. Total. Let me do it the shorter way. Total. This does not affect total. That's num. Return total. So some total numbers. So anything I've left? How possible? For num in nums. If there is a mistake I've done, please let me know. Num in numbers. Total is equal total plus num. We return total. Sum total numbers. Anybody spotting an error anywhere? Let me know if you're spotting an error anywhere. Where have I made a mistake? Let me see. Let me just reduce. See if it's making a difference. How possible? How possible? Yes, the same thing I did even here. Anyway, let me do it again. Okay, so we've defined an iterable, which is a list over here. This is the function, so we are passing the numbers, and let me see if maybe there's an indexing issue somewhere or not, because according to me, I have done it properly. Let me even remove this for now. So let's start from 0 again. So we have defined a function. So this function is supposed to add for us. So we initialize a variable called total. We initialize it to the value 0. And then we want to use the for loop to iterate over the numbers that will be in this particular iterable or list or object. So for num in numbers, for num in numbers, total plus equals num. Let me return. Okay, probably this is the I've seen the reason why. So I need to, yeah, and then let's call the function. So we just print sum num, sum total, and then let's pass in this list now. 1, 2, 3, and see if it's gonna work or not. And if it doesn't work, we find out. Yeah, so it's worked. It's because I put more indentation to return keywords. So yeah, and you can put this outside. The way I put it, I put it inside here. It's the same thing. So if I put, if I add these more numbers here, whatever it is, it will add up to do the math for us. And you can see it's done it for us. Basically the same as the other one. The shortest way, I'm doing this because it's good for you to know how these functions work. However, there's a shorter way of doing this. You can do it just like this. Though, so let me, what am I supposed to do? Let me just say new list. A new list is equal to, I'll be done just now. New list is equal to list. No, do I need that list? Is equal to some nums. Okay. Some nums. And then when we print this one, some nums, and then when we print this, we print the new list, and we should get 15 Yeah, it's working the way we want it. We add more numbers here. It's still gonna work the way we want it. Okay, so you can do it the shorter way. There are several ways of doing this. Now, about your game. How many have seen the game? I've seen the notes I've added to the game. How many were able to, yeah, Brian, okay. How many were able to pull? Okay, please, I know Bobby is going to address that, but let me just give you a hint, because I know it might confuse you a little bit, but I'll give you a hint on how to work on that game. So I will not give you the answer. Please, this is a graded assignment, so take it seriously. We need it back in a week's time, 31st January. So take it seriously, work on it. Read the read.md file, readme.md file. Yeah, so here, now, for instance, first of all, you will need to import what's called random so that you can be able to generate. Wherever you are in a situation whereby you are generating numbers, then you use this library or a module. So import what I was trying to tell you yesterday. I think I've told you sometimes back that some people have worked for us and they're built in these functions, math functions, and all those terms, and several libraries. And so our work is just to import it and then utilize that utility. All right. So I want to choose a secret number. I want to choose a secret number. So this secret number, I don't know it. The computer will find it for me. But I want this game to choose that, but to get that particular secret number for us. So this is how we start. Secret number, let me just write the entire secret number is equal to random dot rand int. So we use this rand int function, and then the range is between 1 and 10. You remember the assignment needs to you look for that particular number between 1 and 10. So we want to look for that particular number. We don't know it, but we need to find it between 1 and 10. So after doing this, then we need to initialize a variable maybe called guess or guesses, which we initialize to 0. Then let's use while. We can use while or while true. All this will still work. So while guesses is not equal to secret number. So while the guesses that the user or the user input is not equal to the secret number, we need a way of the user entering these guesses. So this is going to be an integer. As you remember, this is how we do it. So we just ask, this accepts only strings, and that's why we are converting. So we do this, enter your secret number here. Okay. Enter your secret number. Okay, enter your secret number. Enter your secret number here. That should bring my mouse because, okay. Okay, so while this is the guesses that the user is going to input is less than, it's not, it's not equal to the secret number, which will be computer generated for us, then something needs to happen. So we have to create those conditions. So yeah, so the user will give us something in here in form of our guesses. So what we can say here, if guesses, okay, if guesses, the guesses are less, the guess number, whatever it is less than, it's greater than the secret number in this case, then let's tell let's tell that person that's using our game that please enter a lower number. Okay. And elif, this is why we are testing the use of these keywords. Elif guesses is less than secret number. Then let's print please guess, please guess higher. Okay. And now what we need to do now, we write an else clause so that we exit. So we will tell this user if they have got, because if it's not this, if it's not, and it's not this one, then most likely this is the answer. So we will print here, print congratulations. Let's format this because I like formatting. Maybe you will also like that, I don't know. Congratulations, you have won. So the game ends here. You have won in a certain number of guesses. So you've won in this number of guesses or counts. So let's see if we've managed to hack it and it's gonna work. So let's see. So enter your secret number. So let's say secret number is 3. Please guess higher. 3, so 4. Please guess let's try 7. Please guess lower, let's try 6. Congratulations, you've won in 6. You've won in 6 guesses. In 6 counts. So let's do it again. Let's do it again. Okay. What's happening here? Let me put it here. So let's say 1. Please enter your secret number here. Let's say 2. Enter your secret number here. You please, okay, you're not seeing everything. Enter your secret number here. Please guess higher. So we need something higher. Let's try 7. Congratulations, you've won in 7. In 7 count, you've won in 7, which is not correct because we've not done. Have we done 7 counts really? So that count is not counting correctly. However, you've seen how I've done it. Let's see if I add 1 here. What if I introduce a counter? Let me say, let's say count, so that it can keep tracking of the number of counts for us. Let's initialize this count to 0, and then let's ensure that the count is, yeah, you now know the drill. And now probably what I want to do here, you have won in counts. Let's see if this will work. So I'm not supposed to give you this hint, but I'm just trying to help you so that you'll be able to answer that question the way we want it. Okay, so enter your secret number. So 3. Please guess higher. Let's say 8. Please guess higher. Let's say 10. Please enter lower number. Let's say 9. Yeah, this now works. Congratulations, you've won in 4 counts, which makes 1, 2, 3, 4, which is now correct. All right, any question before we hand over to Bobby to proceed on from there? Are you learning something? So this is a hint. This will help you answer that questions effectively. All right, also over to Bobby. Please proceed on.
Okay. Thank you very much, sir.
You're welcome.
Today we are going to be continuing with Git, specifically Git commands. So that this is the final for the introduction and the basics. This will be the final lessons on Git. Before we shift to something else, we'll get back to Git when we start working with advanced concepts of Git. But for today, we shall cover relevant Git commands. Let me share my screen. I hope the screen is now visible. Okay. Before we explore those commands, there's something we had not mentioned earlier on. There are terms that you will come across when working with these Git commands. There are these 4 different terms. So far, I think we've mentioned the last 2. So we've mentioned what a local repository is and what a remote repository is. So the remote repository is what you clone to your local repository where you work on your changes or whatever you're working on, and then you push your changes to the remote repository. So these two, they sync hand in hand, whereby whatever you push, you pull. So this, we had mentioned these two, but what we had not mentioned is about the staging environment and the working directory. So we are going to see these 2 things. So we said we have 4 new terms that we are going to be using. So the working folder, the staging environment, a local repository, and a remote repository. So the working directory is the local directory. It's what is in your computer. So here is where you'll use git init for this folder to be initialized to allow the tracking of these changes made on your files. So on your working directory, you can also add git ignore. We'll look into that as we conclude. And you're the only one who will be able to access the working directory. The other developers cannot access it. And the changes made, the changes can be, you can work on the working directory even when you're not connected on the internet. So after finishing working on the working directory, then these changes are moved into the staging environment. So the staging environment is the between what is on your machine and what is on the remote or the cloud. So what is on your machine and what is on your GitHub. So this is like in between. We call it the staging environment. So this staging environment, it has this code with the changes that you worked on your machine, but it has not yet been pushed, or it has not yet been published to the remote repository. So in this staging environment, you may choose to revert. You can see maybe I made some mistakes, or somebody else has already done what I was doing. Let me revert, let me undo my changes. So while in the staging environment, you can revert your changes, or you can make other changes before you publish. So you can see I've made a mistake. Let me correct it before now I publish it to my GitHub or the remote repository. So this is the in between. This is what the staging environment is. The staging environment can also be accessed without an active internet connection, because it's the in between. So you don't need the internet connection yet to access it. We had said what the local repository is. This is the what is on your machine. So it's the link between the staging area, the remote repository. It has the changes of what you've done on your machine. While it's in your local repository, you may change, you may revert, you may do anything with it. It has no issue. And it can also be accessed without an active internet connection, since it's on your machine. And then finally, the last term that we need to be aware of is remote repository. This we also had covered before. We had covered what a remote repository is, and we had said it's what is hosted, our repositories that are hosted online, i.e. on GitHub, Bitbucket, or other cloud version control systems. So this usually contains the final published or the committed changes. Now this is what you had pushed after you've worked on them. So this is what moves from the staging environment now into the cloud. And these changes that you push to a remote repository are called commits. And these commits are usually assigned a random unique identifier. We call it the hash. We shall see about that. And to work with the remote repository, an active internet connection is needed. Now, this is where you'll need an active internet connection as compared to the previous uh, terms that we had used. And with the access it, they can make copies, they can contribute to it. So, for instance, the link that was shared yesterday for the game, the one that you're supposed to clone, now that is a remote repository. Now, when you as other developers, you can access it, you can make copies of it, and if you have been added as contributors, you can also contribute to it without any challenges. So up to there, I hope we are okay with these terms. So that was the diagram that we were looking at before we embark on working with Git today. So we had seen several Git commands before. We had seen the Git clone, which we had said allows us to copy the remote repository onto our local repository. And we had seen Git init. So we had said that Git init initializes an empty Git repository. So this initializes and we had seen that this empty repo it initializes is just a transparent, a hidden file that is called .git, and I say that files that have a period before them, these are files that have been hidden. So folder with the configurations for what the contents should not bother you that any much. And when cloning the repository, we said we use git clone, and then we add the URL of the repository that we are cloning. And we had a look at that. So for instance, the repository that was shared with us, if I open my terminal, to close, I'm on my desktop, so I create a new folder, or I can just even clone with like that without any issue. So we said when you say git clone, then you add the link, you paste the link to the URL, so that is the link to the repository. So like when I say git clone, then the link to the URL, you will see it will say cloning into seed class 225, and it has completed cloning. So now I have a copy of what is on GitHub from Peter's account now onto my local machine. I can open it, and then we say when you use code, then a period at the end, that is what opens up the IDE. So you can see everything that is on the GitHub account is also on my local machine. Let me open it on the web so that you see. So these are the contents. It has the README and a file called sit.py. So also on my repository, on my machine, we also have the same. We have the README Python file called sit.py. So I've been able to clone the repository on my local machine. I said that with the remote repositories, other developers can access them, make copies, or contribute to it. So with this repository, it's operator. So if I try to make changes and push to it, so for instance, let me so, and then I just say this is a demo file, and then I try to push it. We'll get into the commands as we continue. So if I say we'll do all of this together, don't worry. For this one, it has allowed for me, let's see. Yes, it has not allowed because it says remote permission to this has been denied, so I'm unable to push my changes. So even though it's a remote repository, unless I've been added as a contributor, I cannot contribute to the repository. So we need first to see about something that is called forking, so that we are able to work with it. So forking, when you open GitHub, through the link, it will take you directly to GitHub. There are these icons and some words up here at the corner. So there is this one that is called fork. So to fork is to create my own copy of the folder, but not locally on my GitHub account. So when I fork this repository, I am creating a copy of the same, but now it's still on my remote on a different remote repository. So for instance, let me fork it. We see with this example. So if I fork, you see what it will do. Okay, it will tell me create a new fork. So a fork is a copy of a repository. So basically, it's a copy of the repository, but it's not on my machine. It's on my GitHub account. So it allows me to make changes on the repository without affecting the main that is on his account. I hope up to there I'm not losing anyone before we get into the command. So for us to work with the commands, we need first to understand this part. So I create a fork. I've created a fork called seed class. So I have everything, but it's now on my account. It's now on my account. As you can see, it's on my account, but it's the same things that are on his GitHub account. So that is what forking does. For this one, you just do it using the graph GUI, like the way I've shown you. And with this fork, you can sync your changes, you can contribute to it, and then the owner of the main repository will decide if whatever you've done is okay, and then they can add them there. We'll get into that. So that was the other thing that I needed to mention about forking. Now onto the Git commands that we will be working with mostly. So these are the ones that you need to have at your fingertips, because we will be using them always. You'll always be using them. If you're working with Git or if you're working with any project, you will be using these commands. So the first command that you need to be familiar with is git add. So when you use git add, you add the file name, or you can say git add then space period. These two are similar, almost similar, but they are used. We will look at an example of both of them. So git add then file name is used when you want to add a specific file. If you want to add a specific file that you've worked on or that you're working on, you use git add, then you type the file name. Then git add space, then full stop. This will add all the files that you have touched or that you have worked on. So I had created a forked repo, so I can clone this one. It will be much easier. I open my terminal. Again, I just git clone, then I paste the URL for that repo. And now you can see you can see now it shows my username, because now it's on my account. But it's still the same repo, but now you'll see it shows my username. So git clone, then the URL. Oh, I already have the other one, so let me create a new folder. Then we use this one, and then I use the arrow up as I had shown you in the previous class. So when I'm using the arrow up, I go back to the command, and now it will clone into my new folder. I've successfully cloned it. Now I open it.
Bobby, your screen is hanging. Your screen is hanging.
Okay. Okay, let me switch to something. I hope I've switched my internet. So what I had done, I had cloned the repository that I had forked onto my desktop, and I was opening VS Code, which I've just opened. So on VS Code, I want to create a new file. I'll call it I'll call it demo.py. So this is the file that I've created, and I'll just write a comment. This is a demo file. As we had seen on our previous class, if you can remember, we downloaded some extensions on our VS Code that will allow us to work with Git, and these files will these extensions will show some things as we continue, and I will comment on each of them. So now you can see here it is writing U. I don't know if it's visible. So here it's writing U. What this U means, as I had said, it means untracked. So this means that these changes that I'm making to this repository are not tracked yet. So if I want this file specifically to be tracked, I will say git add, then I say the file name, so demo.py. That is how this git add then file name works. So you say git add, then the file name that you want to add. So if I say git add then demo.py, so it is this new file that I've created. You will see it has changed to A. So this means that I have just added this file to the staging area, as I had explained before. So I have been able to add this file to the staging area. So that is the first example. Git add, then the file name. As I had said, this is one of the commands that you will be using a lot. The second one, and the easiest that I'd prefer for you guys to be using, is just git add space, then full stop. This is the easiest compared to the file name, because if you have several files that are untracked and you don't know which is which, you just use git add space period, it will add all of them. We'll see how to check which files are untracked. We'll see how to do that. So back to VS Code, I want to create also more random files. So if I say data.py, and then I say we have strings, we have integers, we have float, and we have boolean. Let's say I just say something like that. Okay. I say something like that, the data types. And now I've done that. Now I create another file. This is just an example so that we can see the difference between the two. This is just an example, so don't worry about the random things that I'm doing. I say exercise, or I call it exercise.py, and then I say this is an exercise. So these are just random files that I've created that are untracked, so that I can show you the second command. If you have multiple files that you're working on and you want to add them to the staging area. So this time I'll use git add, then space, then period. I don't know if it's visible. I hope you can see. I've used git add, then space, then full stop. And when I click enter, it has now added these other files that I've created. As you can see, they've all changed to A from U to A. So I've been able to add these files. So when adding files to Git to the staging area, these are the two commands that you'll be using, and it is important to understand how to use them and which one is favorable. So this is the easiest one. It does not have a lot of work, but over time you also get to use this other one. So just know this one. So what this command does is adds individual file to staging area. Okay, and this other one, it adds all changes, all changes or all files that you've worked on to staging area. So these are the two commands that I'd like for us first to know. I'll put them somewhere where they are much more visible. Now I want us to go to the second command, and I'll give you some exercise later on so that we can all be together. So this is git commit flag m, then message. So when working with Git or working with a group or a team, or when working on a project, if you make some changes, you need to inform the rest of the team that I've made change X, Y, Z. So the way you can inform them, instead of now making the changes, then sending me an email or a text telling me that I've made changes X, Y, Z, there are things in Git that are called commit messages. So these commit messages are used to track the changes that you've made. So if you have made change XYZ, you'll write to me a commit message and tell me, I have added these files, I have changed this, I have removed this, and that will be easier for me to see what you've made instead of you making the changes and then calling me or telling me outside of our collaborative environment. So this is what we call commit messages. So committing is now moving the files from the staging area that is pushing. We will see that, but that is what the essence of committing is to write the message for us. So I'll look for a repository. Good. We'll use this one. So you can see the README was updated. So you can see the okay. So on this repository, you can see the changes that were made. You can see this was added 20 hours ago. So I assume that is yesterday. So you can see the commit message was updated by clarifying the instructions. So this is the new commit message. Instead of me asking him, what did you do to this specific file? He has written the commit message, which is updated by clarifying the instruction. So it means that this sit.py file has been updated and the instructions have been clarified. And now you can see 6 hours ago, updated readme. So now this is just tells me that he has updated the content of the readme file. So that is the essence of a commit message. Instead of now me wondering what changes he made or what he did to these files, by the use of the commit message, I'm able to understand or to know what he was able to do. So for me, on this repository of mine, I've been able to add 3 different files called data.py, demo.py, and exercise.py. So if I want to commit these changes or write a commit message, I'll just say git. I'll just say git commit this space dash m. This dash m is what indicates the message. Then I say added some files to the repo, something like that. Now this is my commit message. Added some files to the repo. You can see the file. My commit message is not clear. Added what files? So there is a way that these commit messages are supposed to be written, but for now, since we are still learning, you can write it as long as it makes sense to you or to the reader. It's okay, but there are certain way that you're supposed to write them. For instance, for this one, I would have written added 3 files or added demo or whatever. But now, for now, since we are still learning, we'll just say added 3 new files. So it's a bit specific. Added 3 new files. So this is my commit message. So git commit flag m. This is my commit message. I've added 3 new files. I hope it is visible. I hope it's much more visible compared to the other. Or I go back to the other one. So this is the git my commit message. So git commit, I've added 3 new files, and you can see the essence of git. It is tracking, so it is telling me I've changed three files. I have 6 new insertion. I've created this file, this file, this file. So the git is already tracking whatever changes I am making. So we go back to the command. So this git commit, so this used to so the essence of this one will be using it to write commit messages to our changes. Okay, so this is the second command, git commit flag m, then the message, and this message needs to be in quotation marks. So an opening quotation mark and a closing one. Now we go to the final command that you need to have at your fingertips, which is git push. So what git push does, it now pushes the changes, or it publishes the changes. So it moves the changes from our staging area to our remote repository. So now if I want the changes that I've made to now appear on GitHub, I'll just use git push, and it will push my changes to GitHub or to my remote repository. So I come here, I say git push, and then let's see, it will tell me I'm unable because I'm using a different account. This is logged into a different username. Let me switch to that username.
Bobby, are you sharing the screen?
Yes, I'm sharing the screen. Can you guys see my screen?
Yeah, I
Yes.
can see it.
Okay. Or let me switch to that other username that I. Okay, I've switched to that, so it means that everything that I've done here. Let me try first of all. Okay. I know what I'll do. A minute, please. So for me, my Git has some settings. So this is my my GitHub account. So it has some settings, and sometimes it may not allow the committing from different repositories, but it's because I have some settings that I had put on. That is the only reason, but otherwise it's supposed to allow. But I have some specific settings. That is the issue. Okay, I have accepted. Okay, now that push commit, I'll explain everything later. Let's first see if it's still saying unable to access.
Is it private? Is it private?
The cloned repository is public, but
let me see the message. It could be because
yeah.
that file is opened in VS Code. Let me see. Yeah, can you close the VS Code and then try to push this one?
Okay. For this one, it's working. Oh, yeah, it's working when I push using the terminal. So I'll repeat that. So these commands that I was showing before the issue. So I'll create just another file. There's no problem. Demo2.py. So demo file again. Okay, then I try now to commit again. So we said the first command. The first command we said is git add. You can put the file name at the end, or you can use a period. So whichever you find easy or whichever you find works for you, you can use that. But for the sake of this example, let us be using the space full stop one. It's the easiest one. So git add space period. And then the second command is the one for commit message. Yes?
Just clarification.
Yeah.
The other one is for a specific file, isn't it?
Yes.
Yeah. For instance, if you make a change, a single change on a particular file, then you want to add just that particular one. But if you add a period, then the entire changes made in that project will be affected, isn't it?
Yes.
So you
Yeah.
want
Yeah.
many changes, so you use the period, right?
Yes.
Yeah. Okay. Perfect.
Okay. Thank you. So when we want to now commit our changes and write our commit message, we use git commit, then that flag m. Then we can now write our commit message. So I'll say I'll say added the demo2.py file. So I'll say this is my commit message that I've added a file called demo2.py. And then you can see Git is already tracking these changes. It is saying one file changed, one insertion, and Git mode, all of that. So now I can push these changes. So we say git push, and it will now push the changes to the remote repository. Now it has worked easily because the other one has some changes I had to make. So you can see it will tell you git push. It will tell you something like this. So it has successfully pushed our changes from our local repository, from the staging area now onto our remote repository. These all have different meanings, but we won't get into that for now. So as I have said, the basic commands that are important, we said git clone, then URL. I hope you'll remember these commands. These are the ones that you need to have on your fingertip. We also have seen git init. Today we have seen git add, and then file name for a specific file. We've also seen git add space periods for the entire changes that you've made, all the changes, all the different files. For that one, we've also seen git commit flag m, then commit message. We've seen this, and finally we've seen git push. So this is pushing our changes now from the staging environment of our local repository to our remote repository. So far we've seen these commands. Now you remember this diagram? We had the staging area, local, and all of that. Now we want to see a command, the command that we'll be using to differentiate between to see the changes that are untracked, to see the changes that we've added, and all of that. So the commands that we'll be using, the first command that I want us to know is git status. So the first command is git status that we'll be using, git status. So the first command will be git status. So the first command will be git status. So what git status will do is it will show us the changes or what we've done. So for instance, if we run git status right now, it will tell us that our branch is up to date. There's nothing to commit. Our working tree is clean, or our working repository is clean. So basically, this git status tells us the status of our whatever we are working with. If we have files that are in our local repository that have not been added to the staging area or have not been committed, this will tell us, by using git status, it will tell us if our branch is up to date with our remote repository. So git status will tell us if whatever we have on our machine is the same as what we have on our remote repository or not. So for instance, let's create another new file. We see the difference. So we create a new file. Let's call this index.html. Okay, we put a boilerplate there as usual, and you can see it is written U. The extension that we have is writing U. So this means that this file is untracked. So if I come here and I say git status, you see it will tell us we have untracked files. Okay, so it tells us we have untracked files. So there's nothing added to commit, but untracked files are present. So it is telling us the status of our working repository. It tells us that we have files that are not tracked, that we can add them to the staging area. So that is what git status does. That is the other command that we were going to be looking at. The other one is git log. So git log is from the name log. For instance, when you are working at a workplace whereby you have to check in the morning, you have to sign in that you have entered, and when you leave, you have to sign out that you have left. So for them to see who entered at this time and who left at this time, there are files that are called log files. So these log files, they show the history. They show the history of who entered, who did not come, who left early, and so forth. So these are what are called log files. So with Git, what we use with Git log is to show us the commit history. So we will use Git log to see the history of our commits. I'll show you something shortly, but first let's see what Git log does. So Git log. When you use Git log, it will show you something similar to this. Okay, so I wanted to reach the end so that we see. Let me go up to the initial end. Okay, so this is it. So this is what we call a log file. So this log file is tracking the commit history since this repository was created. So this commit history we can see at Sunday at 4:15. The first file, the initial file, was added. At this is 11:43. A README had been added. At 11:52, the README was updated. At 11:57, the SIT file was also updated, and so forth, up to where I was working on it. So you can see this is how it is able to track the changes. It gives you the log. So this is what Git log does. It shows us the commit history. And this Git log, these logs have different parts to them. So for example, this is a log. So this log has this first line, which is the commit hash. You remember here we were saying that. Yeah, here it is. So each committed and published change, made is assigned a unique identifier, a random combination of encrypted characters. So that is what is called the hash. So that is what we have here. That is the first part. Let me zoom in a bit. So this is the hash. You see, it's a random.
Sorry, Bobby. Just to add on,
Yes.
that hash can be used to track that particular commit or that particular log. If you're looking for, if you maybe want to amend something and you can't remember certain things, you can pick up that hash. That's secure. It's made using a secure hash algorithm. It's just a key, like a secret key to track that particular commit. Yeah.
Yes, thank you. Yes, that is what the hash is, as we've seen when we say git log. The second part is the author. So the reason we were configuring our Git, we were putting our usernames and our emails, is so that when we are collaborating together, Git will be able to track these changes. So you see, it gives it a hash, it tells you who the author is, the time they made the changes, and then the commit message. So these are part of what the Git, the log files for the commit history up to, you see, and the first one is always the most recent, and you go further down to the initial one. So as you can see, these were the most recent one from me. So let's also see another way of using git log. Okay, so we've said that we use git log to show the commit history. But you've seen it long, right? We've seen that this git log gives us a very long, a lot of things that are sometimes distracting. So there's a shorter way to use this git log. We say git log -- one line. So essentially what we are saying is that we want all the logs, but in a simplified or in a shorter form. So we say git log -- one line, and you can see it gives me the logs in a simplified form. This was what we were seeing before, but we were seeing it much expounded compared to what we are seeing now. So with git log one line, we are able to see a fraction of the hash. We're not able to see the whole hash key. We're not able to see the author. You see, we're not able to see the author, but we're able to see the commit messages and a fraction of the hash keys. So that is what git log one line does. And then there's this part up here, which says that the head is at main. We will see about the head and the position of the head when we are working with branches shortly. But for now, these are the commands that I wanted us to be familiar with. The final 2 or 3 commands that I want us to be familiar with. Let me do something manually up here. So I have refreshed my repository on GitHub, and you can see the changes that we've made. You see 22 minutes ago, 12 minutes ago, 22 minutes ago. So what I want to do something style Mutu. So let me just add a random file. I create a new file. I name this file index2.py. Okay, and I just write this is another file. So now my whatever I'm doing, I'm creating a file on GitHub that I don't have on my machine. So you see I have an index2.py here. Let's see the files that I have on my machine. So on my machine I have data.py, demo.py, demo2, exercise.py, index.html, readme.markdown, and sit.python.py. These are the files that I have on my local repository. But on my GitHub, you can see we have a new file that I've just added manually called index2.py. So these are changes that I have on my GitHub that I don't have on my local repository. So a command that you can use here, remember here we were pushing to publish our changes from local to our GitHub or to our remote repository. Now the opposite of push is pull. So if I want the changes that are on GitHub that are not on my machine, I will use git pull. So this will update my local repository with the content that is on my GitHub. So if we say, let's see, git status first, this or the untracked file, so we cannot add this without pulling. So we'll say git pull, and you can see remote, the objects have come in. You can see the index2.py file is now part of my files. If I say, you can see it now appears as part of my files because I've used the git pull. Now the git pull updates my local, whatever is on my machine with whatever is on GitHub. So if we are working with someone else and they add different changes to whatever we are working on, the copy that I had cloned before does not have those changes. So I have to use git pull to get those changes that this person we are working with has added. So that is the use of git pull. So these are the commands that we've seen. We've seen git clone, git init, git add for a specific file, git add space period for all the files that we have been working on. We've seen the commit messages and to pull. We've also seen git log and git log one line. They're the same, but this is a much shorter version of whatever are on the log files. We've also seen git status, and now we've seen git pull. Now we've seen git pull. I want them all on one page. Yeah, so these are the commands that we've looked at. There are many commands when working with Git, and some of them you probably will never use. Some of them you'll use often, and these are the ones that you'll use often. The command that you will be using frequently. That's why I have covered these ones first. So these are the commands that you'll be using every now and then. So it is essential that you have them at your fingertips. There are several commands that I have not mentioned. We will mention them when we are working with advanced Git. So there are things like branching, merging, there is rebasing, there is hard reset, and several other commands that we have not mentioned that we will have a look at them. And these commands are many. And as you're starting out, you may not have them at your fingertips, or you may not have them memorized. But over time, you'll memorize them and you'll work with them frequently. But before then, there is something that we call a cheat sheet. So a cheat sheet has these commands listed somewhere where you can reference them from time to time before you gain mastery or before you become more familiar with Git. So if you just go to Google and search Git cheat sheet, like that, Git cheat sheet, it will give you a list of several. The one that I recommend is this, the first one from GitHub Education. I recommend this one. I also recommend the one from Geeks for Geeks, and also the one from training. I'll add the links to them. Let me paste the links to these ones on the chat. So they will download a PDF on your gadget. These links will download a PDF that has the cheat sheets. So these cheat sheets will help you familiarize yourself with these Git commands and explore further where you've not understood. I downloaded it so we can have a look at it. And this is the one that I want you to download, the first one. It's the best. It's the first link that I've shared. This is the original one from GitHub Education. It covers the installation, which we had done. It also covers the setup up to this part. This one you can ignore. This one for now, just ignore it. Then it covers the first commands. It tells you the command and what it does, as we had explained. And then it has this other Git command. So like for Git status, it shows there's another one called Git differentiate. There's Git reset. You probably won't use all of them, but the cheat sheet will have the commands. We will look into branching and merging when we are working with advanced Git. For now, we've seen Git status, Git add, and Git commit. Ignore the rest for now. And then we've seen Git log and the different types of logging mechanisms. They should not bother you for now. We've not looked at this and the stash one. Those are advanced Git. We will cover them when working with advanced Git. We've also seen how to push and how to pull. The rest that are remaining, we will work with them when we are working with advanced Git. For now, I want to mention one thing about ignoring patterns. So with Git, there are files that when you're working on, you don't want these files to go to the remote repository. These files can be secrets, API keys, things that you don't want exposed to the public. So for instance, this repository that we were working on is public, right? That means that anyone with internet access or with the link or who knows my GitHub username can access this repository. So if this repository has files that I don't want these files to be public, these are files that I don't want them exposed to the public. Maybe they are secrets to whatever project you're working on. Maybe it's the code base to whatever you're working on. I don't want this code base exposed to the public. So there's something called git ignore. I want us to have a look at that. Let me new repository. And then git ignore, learn more about ignoring files. Yeah. So this git ignore files. Okay, so these git ignore files, they are different depending on whatever language you're working on. There are different ones for Python, for Rust, for Go, for all the different programming languages. And when you are creating a new repository, you'll always be given this option, add a .gitignore file. So if your repository is for a Python file, you can just search Python and click on Python, and it will add, let's just create a random name for that repository. And we've created a gitignore for Python files. So this will add for you a gitignore file. So this gitignore file will contain some of the files that are either irrelevant or will be different on your developer environment compared to mine. And sometimes you can use it to ignore your env for the secrets and so forth. When you're working with advanced Git, we will look into them, and also about licenses. I just wanted to mention it because it is in the cheat sheet, so for you not to bother with it. For now, we just want these basic commands that we've seen. I will share a screenshot with these commands to the WhatsApp group, but these are the commands that you'll be working on. So for the remaining minutes, if you were stuck anywhere or have had any question, you can ask and we will work together on it. Yes, I see a raised hand. Catherine.
Remove the recording now, Bobby.
Okay.